This video is going to talk about writing inequalities from word problems. So we're just going to go through a few examples and we're going to set up an inequality based on the scenario that's given to us with the information in the word problem. I'm not going to go through and solve these here because I want to just practice setting them up, and there are other videos about how to solve these once you have some particular information, or how to graph these if you want to see what the solution set looks like. So we'll start with our first example here. A landscaper is purchasing plants from a nursery to finish a project. Trees cost $10 each and bushes cost $11 each. The landscaper has a budget of $1,400. So we can say that T equals the number of trees he purchases, and that B equals the number of bushes he purchases. Then the amount of money he spends is going to be 10 times T, okay, because if he buys 3 trees, that would be $30, because I do 10 times 3. So he's going to spend 10 times the number of trees he buys, okay, $10 on each tree. Then he's also going to spend $11 on each bush. So if he buys 5 bushes, I'm going to do 5 times 11 and get $55 for those 5 bushes. And this is the amount of money he's going to spend, okay? Money spent. And he wants that money to not exceed $1,400. He can't spend more than $1,400. So we know that the amount spent has to be less than $1,400. Now, one question here is whether he can spend all of the $1,400 or not, and I would say that since it says a budget of $1,400, that yes, he could spend exactly $1,400. So our inequality says 10t plus 11b is less than or equal to $1,400, meaning that he's going to spend $10 on each tree, $11 on each bush. Then we calculate the amount of money he's going to spend, and it has to be less than or equal to $1,400. Our second example says that a tour direction, which actually should say a tour director, okay, someone who is organizing a tour director is hiring boats to transport a group of tourists across a river. He must make sure there is room for at least 28 passengers. A dinghy can seat 5 passengers and a flatboat can seat 3 passengers. So we know that a dinghy can seat 5 passengers. So we'll say D is the number of dinghies used. I guess when you pluralize dinghy, it goes IES. And let's call F the number of flatboats that are used. So there are 5 people on each dinghy. So if I was going to use 2 dinghies, that would be 5 times 2, 10 people could fit on those 2 dinghies. Plus, we can fit 3 people on each flatboat. So if I were to have 6 flatboats, 3 people on each, I could have 18 people on flatboats. Now this is the number of people traveling on the boats. And we need the number of people to be at least 28. Okay, there are 28 people currently signed up for this tour, so we need at least 28 people to fit on these boats. The phrase "at least" implies that we can also be equal to 28. Okay, so 28 people could fit on whatever combination of dinghies and flatboats we come up with given this inequality, or it could be more than that. Our third example says, Carter is determining the seating arrangement for his big graduation party. Circular tables can seat 12 guests, and rectangular tables can seat 8 guests. So far, 176 people have responded to his invitation saying they will attend. So this last sentence here doesn't have any direct math words for us, but given that we know that 176 people have said yes, we can assume that perhaps more than that will show up, and he wants to guarantee that he has seats for those 176 people. So I would say that this means that we have to have at least 176 seats. So we need to define our variables. We'll have C be the number of circular tables, and R be the number of rectangular tables. So then there can be 12 people at each circular table, plus 8 people at each rectangular table, and we need that to be at least, which in our last example we saw means greater than or equal to, we need that to be at least 76 seats total. So our inequality is 12C plus 8R is greater than or equal to 176. Our next example has Sarah and her family going to the movies. A small popcorn costs $7 and a small soda costs $4.50. Sarah has offered to pay for popcorn and soda with the $36 in her wallet. So here, this is a constraint on the maximum amount of money that she can spend. 36 is the maximum. Now she could spend all 36, so we know that we're going to have an or equal to situation. So P is the number of small popcorns she could buy, and S is the number of small sodas she can buy. So 7P is going to be the cost of all the small popcorns she buys, plus 450S is going to be the cost of the sodas she buys, and this all has to be less than or equal to $36. She can't spend more than $36. Our last example says yellow cab taxi charges a $1.75 fee in addition to 65 cents per mile. Katie only has $10. So in this case, there's actually only one variable, and that's the amount of miles that Katie is going to be able to travel in this cab. So just to get in the cab, you'd pay $1.75, and then after that, you pay 65 cents for every mile. So let's have M be the number of miles traveled in this cab. And since she only has $10, she can't spend more than $10 on this cab ride, but she could spend exactly 10. So she's going to spend up to or equal to $10 on this cab ride. So $1.75 plus 65 cents a mile has to be less than or equal to $10 in order for Katie to take a cab ride.